Hello everyone, welcome to OneClass. My name is Shanjida, and today I'll be going over some commonly asked chemistry questions, both at the high school slash university and college levels. And so I'm also currently a second year human biology student. And lastly, if anyone needs additional schoolwork help or needs tutoring, you guys could check out the description box below. And other than that, we'll get started. So the first question for today says, what is the molar mass of copper 2 sulfate? Okay, so copper 2 sulfate. Right, so they're telling us to find the molar mass or the molecular weight of this compound here, and you can see that they have given us the name of the compound, but we need to first figure out the chemical formula, and that is a crucial step in order to find the molar mass. And so the chemical formula for copper 2 sulfate is CuSO4. Okay, and so in this case, you can see since it's copper 2, we know that we're using copper 2 that has a charge of 2 plus, and we know that our sulfate ion has a charge of 2 negative, 2 minus, right? So when you combine these two, you get copper sulfate. And so this is your chemical formula for copper sulfate, and now we can find the molar mass. So let me write molar mass as two M's, two capital M's, and you have copper sulfate. And this would equal, so we would basically break this compound down into the individual elements, and in this case you can see we have three. We have copper, sulfate, and oxygen, so we would write it out like this: the molar mass of copper plus the molar mass of sulfate or sulfur, and the molar mass of oxygen. And in this case we have 4 oxygens, so we're gonna write O4. So now let's start off with finding the molar mass of copper, and this is given in your periodic table. And so if you zoom into our periodic table, we can see that copper is group 4 and it has an atomic number of 6 and it has a molar mass of 12.0. Oops, this is carbon, sorry. So copper is right here. It is a transition metal. It has an atomic number of 29 and its molar mass is 63.55 grams per mole. If you guys recall that the molar mass, the units for molar mass is grams per mole. And so that is basically your mass divided by the number of moles. And for copper, it is 63.55 grams per mole. And so now let's switch over to sulfur. Sulfur is group 6 and it has a molar mass of 32.06 grams per mole. Okay, so now let's do oxygen. And in this case, oxygen has a molar mass of 16, but before that, we know we have 4 oxygens, so in this case, we would have to multiply 16 by 4, since the molar mass of one oxygen atom is 16, and so to get 4, we would have to multiply that 16 by 4. Okay. And now we can basically simplify. We have 63.55 grams per mole plus 32.06 grams per mole, and 4 times 16 is 64. Yep, 64.00 grams per mole. And the last thing you would do is add these three numbers together, so you'll have 159.1 grams per mole. Okay, so the molar mass of copper 2 sulfate is 159.61 grams per mole. And let's see, so yeah, this is what they've got. The solution is correct. Okay, so our next question says, what is the molar mass of iron? And so the molar mass, so let me write this down here. Mass of iron. So iron is has a symbolic letter of Fe, which is it's a scientific symbolic representation for iron. And so the molar mass of any element, since iron is an element, it's not a molecule or compound, so it is just the atomic mass of the element expressed in grams per mole. So the molar mass of iron, you can say this is basically your atomic mass unit of iron. And so this is actually provided by the periodic table of elements. And if you go to our periodic table over here, we have defined iron. Iron is a transition metal. So you can see it's right here, and it has a molar mass of 55.93. You can say this is AMU or grams per mole, it's basically the same thing. So you can say that has a molar mass of 55.93 grams per mole. However, there is another way to find molar mass or your atomic mass unit of any element. So if you guys recall that your atomic mass unit is basic. So to find your atomic mass unit of any element, this is your number of protons plus the number of neutrons, right? And so in this case, let's say for iron, we have, so the number of protons is always the same as the number of electrons or your atomic number. And in this case, it says this is 26, so you can say it's 26. And so in most cases, your number of neutrons is also the same as your number of protons, but in most but in usually rare or like really less cases, your neutrons will be less or higher than the number of protons. But we can assume, just for a brief example, we can say that your neutrons is also the same number as your protons, so we can say this is also 26. And so we can add these together, so you get 52 of your iron, and in this case you can see it's 55.93. So from this you can say that your neutrons is probably a bit higher than your protons, so we can say that this is around, let's say this is 29. Oops. Around 29, and so you get 50, 55, right? Or it could be 30 or something like that, right? But in most cases, your neutrons and your protons will be the same. So just write a star in most cases. number of protons equals the number of neutrons for most elements, but in some there aren't. And so this is one way to find your atomic mass unit, which is the same thing as your molar mass. But so one key difference, I'll just write one key difference between molar mass and atomic mass is the unit. So for molar mass, you know, this is grams per mole, right? And for atomic mass unit, we know that this is atomic mass unit. We write this as AMU, right? So that's the only key difference. Okay? And so this is, so basically this is correct. Okay, so next question says, what is the molar mass of phosphorus? Okay, so molar mass of phosphorus. So phosphorus, if you guys recall that phosphorus so you represent this, the symbolic form is just the uppercase P. And since phosphorus is an element, we can just basically look at our periodic table here and find phosphorus. And so phosphorus is group 5, and it has an atomic number of 15 and a molar mass of 30.97. So we can say this is 30.97 grams per mole, right? So this is given in your periodic table. However, as I mentioned in my previous questions, that your molar mass is basically the same thing as your atomic mass. So AMU. If you guys recall, AMU, to find your atomic mass unit or your mass, is you calculate the number of protons plus your number of neutrons of that element. So in this case, let's say we're trying to find the atomic mass unit of phosphorus. We can say that the number of protons is basically the same thing as your atomic number over here, which also represents the number of electrons. So electrons, and we know that the number of electrons equals the number of protons. And so in this case, we have 15 protons. And to calculate the number of neutrons this is basically the same in most cases, or in majority of the cases for elements. The number of neutrons is also equal to the number of protons. So we can say this is also 15. And so you just add this up and you get 30 AMU, right? And so this is also, so you can also say this as 30 grams per mole. You just have to convert the units, and so this is what molar mass is equal to, right? And you can see it's roughly that. However, your neutrons, so your protons do not change the number. It's always your atomic number. However, your neutrons can change. This is what makes it, this is what isotopes mean, or different elements. But if you're trying to find like roughly your atomic mass, you can use this method where your number of protons is equal to your number of neutrons. And so This is correct. Our next question says, which of these statements are true for a neutral aqueous solution at standard heat, so which is 25 degrees Celsius? So we're given three conditions and we have to see which one of them are true. So basically, when an aqueous solution is neutral, it must have a pH that is equal to 7. That's one of the most important conditions that needs to be fulfilled in order to establish a neutral aqueous solution. Okay, so we can say a neutral aqueous solution must have a pH of 7. Right, if you guys recall our pH scale, so this is our acidic part, and this is our basic. So you can see, like, on the left-hand side that your acidic ranges from anywhere from 0 to, let's say, 6.5, and basic is anything from beyond 7. And 7 is your neutral. And so for any neutral solutions, they must have a pH of 7. So this is like water. So water has a pH of 7 because it's neutral. And basically, if the pH is less than 7, then the aqueous solution is acidic. That's one of the true statements. Thus, one of the true statements is that the pH of the solution is equal to 7, right? And so it's number 2. So also, if the solution is neutral, then the concentration of your H plus ions, so your hydrogen ions and your hydroxide ions must be equal. So that's why, that's how you know you don't have something of, if you have more of your hydrogen ions, that means your solution is acidic. If you have more hydroxide ions, that means your solution is more basic. And so when it's neutral, they both basically cancel out each other, and that's how it becomes neutral. So we can say uh, another statement. So, for another statement is that for a neutral aqueous solution, the concentration of your hydrogen ions and hydroxide ions must be equal. Okay, this is because, as I just mentioned, that if you have more of your hydrogen ions, it would be more acidic. So let's say if you have an increase in hydrogen ions, okay, this means you are more acidic. Compared to your hydroxide ions, and if you have an increase of your OH ions, that means this is going to be more basic compared to your hydrogen ions. Okay, but however, if your hydrogen ions equals to the concentration of your hydroxide ions. This basically cancels out the acidic and basic components, I would say, and it would make the solution neutral. Okay, so that makes sense. And so this is one of these statements. And we can see that number 4 is one of them, right? And so, so to prove this, we can basically come up with an equation where, so if you guys recall that the pH of a solution is related to the concentration of your hydrogen ions, and so we can basically write out an equation that represents this, and this could be said by so your concentration of hydrogen ions is basically the same. To find it out, or to solve, or to find this the concentration of your hydrogen ions, you would have to take 10 to the power to the negative of your pH. Okay, in this case, you need to know the pH in order to find the concentration of your hydrogen ions. And this, we can say this is our equation number 1. And so we can say the concentration of your hydroxide ions can be related to your hydrogen ion concentration by a second equation, where, if you guys recall, the constant, your ion constant for water, and ion constant dissociation of water, which is Kw, is equal to the concentration of hydrogen ions times the concentration of your OH ions. And this is equal to a constant number, which is 1.0 times 10 to the power negative 14. Okay, and we can say that this is our second equation. Okay. And so if the pH of the solution is 7, let's say, which is neutral, then its hydrogen concentration is, so to find out the hydrogen concentration of a neutral solution, we could say that since our equilibrium for our constant for water ion dissociation is 1.0 times 10 to the power negative 14, and if you want a neutral solution, we know that both of them, both the ion concentrations would be equal. So basically you can say so let me write this in. So for a neutral solution, of a pH which is equal to 7, the concentration of H, let's say H plus, is equal to your OH ions, right? So we can say, given that our Kw, which is equal to the concentration of hydrogen ions multiplied by the concentration of hydroxide ions, is equal to 1.0 times 10 to the negative 14. We can basically find, let's say, like we can find the concentration of our hydrogen ions, and we can say that this, negative 14. We can say that this is your hydrogen ions is equal to your Kw over 2. We can say that this is half of the number of your Kw, and so this would be 1.0 times 10 to the power 7. Okay, so in this case, you can see that this is 1.0 times 10 to the power negative 7. So this means that this, so this also means that since your hydrogen ion concentration is equal to your OH ions, so this means this is also equal to 1.0 times 10 to the power negative 7. Okay, and so we know that, so then therefore we can say since Kw is equal to your hydrogen ions plus your OH ions, right, we can say that this is 1.0 times 10 to the power negative 7 times 1.0 times 10 to the power negative 7. And this is equal to 1.0 times 10 to the power negative 14. Right? And so basically, this is how you can prove that a neutral compound will have a pH of 7 and that your hydrogen ions and your hydroxide ions concentration would be equal. Okay? And so from the statements below, we can say that number 2 and number 4 are correct. So therefore, the answer is D. The solution is okay. So our next question says, how is this conjugate acid and bases identified? And so basically, a conjugate acid is an acid that has one more hydrogen atoms than one more plus charge than the base that formed it. Okay, so basically, as you guys know, the acids have more hydrogen ions and a charge of +1 than the base that formed it. And so, since you guys know that bases have an OH, an O hydroxide ion attached to it, and in some cases it also has a negative charge. And so, a conjugate base contains one less hydrogen atom and one more negative charge that formed the acid that than the acid that formed it. And so, let's say for instance, or for example, we have an example so let's say we have an example of an ion, bicarbonate ion. We can say, for example, we have bicarbonate ion react with water to produce carbonic acid and hydronium ions. Okay, so we have a ion that reacts with water. So we have HCO2 negative plus H2O will produce carbonic acid, right? So the pattern over here, you guys could probably see that this is our base, right? So we said that our bases have a negative charge, and they usually have one less hydrogen than your actual conjugate acid. And so this would be our base. So this therefore makes it water our acid. And so we can say that carbonic acid is our conjugate acid that came from our base. And our hydronium ions in this case would be our conjugate base. And so we can see that our bicarbonate ion becomes our carbonic acid, and it has one more hydrogen atom and one more plus charge, or has a plus one charge, right? So it goes from a negative to a positive, so you just added one more charge to it. And so we can say that our carbonic acid is the conjugate acid for our bicarbonate ion. And on the other hand, we have water that acts as our acid, and this becomes it dissociates into hydroxide ions. And so since it has one less of a hydrogen, um, it is considered a conjugate base, and it also has a negative charge, so this is also why it is considered a base. And in this case, it would be conjugate base, right? So since it goes from an acid and it loses an hydrogen, and it also produces a negative charge, so it would be a conjugate base. And so this is okay. So our next question says, select the correct impact name for the following branched chain alkane. Okay, so let me draw this out first. And we have CH3, CH2, CH3. Okay, get that CH. So you guys could see, since it mentioned an alkane, we don't have double bonds or triple bonds. Okay, and we have CH3, CH2, CH2, CH. We have CH. Okay, so now since we have drawn up this compound here, the first step would be to find the parent chain. Okay, find the parent chain. So your parent chain is your longest. Your parent chain will have the most number of carbons, and so we can basically count either ways from the structure to find which one of them will have the most number of carbons. Okay, and so let's do that, and let's start off with this end. Okay, so let's say so if you count across, we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have 8 across. How about we can basically go from top to the left side? So what I mean, we can say, so we have, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. So we can say that this could be our parent chain, because when we went across, it was 8, and so since 9 is bigger than 8, we can say that this part of our chain is, so we can say that in this case, we can say that this whole, so let me say that this whole chain that's going from top to the left side would be our parent chain. So So let me say that this whole chain right here, except for that methyl group, is our parent chain. Okay, so our parent chain over here. So since it's 9 carbons, we would write this as non. Okay. And so the next would be to identify the groups or the substituents attached to the parent chain. Okay. And so we can say, so looking back at our structure here, we can say, so this is the parent chain, and we can see that we have 3 groups attached to it. So let me use another color for that. Okay, and so you can see that we have a methyl group right here, an ethyl group right here, right? We know that this is an ethyl because it has 2 carbons. And we can say that we have another group right here, and this is a 1, 2, 3, 4. So this is a butyl group. Okay, so let me write. So this is a butyl group. So this is a butyl group. Okay, and so this, as we mentioned, so this was our ethyl, and this is our methyl. Okay, so since we've found our substituents and our groups, this now, able to find or identify join. Okay, so we have, in this case, we have methyl, ethyl, and butyl, right? And so our last step would be to, or second last step would be to now write the position numbers and the names in alphabetical order. So write the position of the substituents in alphabetical order. And so you guys can see that our substituents are methyl, ethyl, and butyl. So from these 3 substituents, going from alphabetical order, you know that butyl is first since it starts with a B. So we can see where our butyl is attached to. So one way we want to go to see which carbon is attached to. Let's start off with counting our carbons this way. So let's say, so this is 1, 2, 3, 4, 5, 6, 7, 6. So 5, 6, 7, 8, 9. So one reason why I didn't go from the opposite side is because we want our substituents to be on the less number of carbons. If you went this way, so in this case our 9 would be 1. This way our substituents would be on a higher number of carbon. And so in usual cases, we want to write our substituents on a carbon that is basically not like a high number of carbon, if that makes sense. So this is why I numbered it this way. And so you can see that butyl is attached to the second carbon. So we can say our substituent position for butyl is butyl. Butyl. So next, for our substituents, E comes before M, so the next would be ethyl. And so let's see where ethyl is attached to. Ethyl is attached to the sixth carbon here. So we can say that this is 6 ethyl. And so lastly, we have methyl, and let's see where our methyl is attached to. Methyl is attached to a third carbon, so we write 3-methyl. Okay, so now that we have found our position of the substituents in alphabetical order, our last step would be to name the alkane. In alphabetical order. By our substituent. And then before the name, or let's say before the name, before the name of the parent. So lastly, what we can say, so we would just name our alkane, so with our following alphabetical order of our substituents. So we would say the first one will be 2-butyl, following by 6-ethyl. And then we have 3-methyl. And lastly, since our parent chain was nonane, we wouldn't put a hyphen here, we would just put nonane. Okay, so this is the name of our alkane. Okay, 2-butyl, 6-ethyl, 3-methyl nonane. You can see that they've got, so the solution is correct. Okay, so our next question says, explain why the molecule fluoromethane is 4. Okay, so fluoromethane, why is fluoro which is CH3F. Okay, so since we're given the chemical formula for fluoromethane, we can basically draw out the structural geometry of this. And so it's given over here, since we have four atoms, or three atoms, and um, one hydrogen is in three atoms. So in this case, this would be a tetrahedral geometry. So we can say that this is a tetrahedral where the carbon is in the middle. You have fluorine, hydrogen, and hydrogen. So this is your structure for chloromethane, and now we're supposed to find why it is polar and not nonpolar. So though it contains four polar bonds, um, basically the magnitude of the bonds are basically different. What we mean by this is that, as you guys can see, that there is in this case, there is a carbon and fluorine bond, and carbon, when we're talking about polar and nonpolar, we're talking about electronegativity. And since carbon and fluorine do not have the same electronegativity, they're basically quite different. Fluorine, I suppose, has a higher electronegativity than carbon. It's more than just 0.5. So this is why, so fluorine has a higher electronegativity than carbon. So this is why the fluorine is slightly more negative than carbon, and so this is how we would write it. It would be okay. And so this is why this makes the molecule polar, even though it is a tetrahedral geometry. It's because of the carbon, so the carbon fluorine bond is very polar. Due to a high electronegative difference between fluorine and carbon. And so this is why, and your electronegativity is given in an electronegativity chart. So to find the electronegativity difference, you just have to subtract the higher number from the smaller number, and you get your electronegativity. And for this case, fluorine is creates a more high electronegativity difference than between the carbon and fluorine bond, and so this is why chloromethane is polar. So this is correct. Okay, so our next question says, is carbon carbonate solid or aqueous? Okay, so let me is so this is calcium carbonate. solid or aqueous? Okay, so basically, if a substance can dissolve in water, it is said to be soluble and aqueous in form. Um, so basically, to find if a substance is aqueous, so to determine if a substance is aqueous or solid, what we need to do is basically determine the solubility. Mm, need to determine and so group 2 elements combined with carbonate if there's a chart for this solubility chart. So in general, what it states is that um, group 2 elements, which is calcium in this case, when they are combined with carbonate, are generally insoluble. So we can say that group 2 elements, right? In this case, calcium is one. When combined with carbonate, are generally insoluble. So if it's insoluble, we know that this is not aqueous because it does not dissolve in water. And so you can say that, therefore, calcium carbonate is is a solid. Okay, so answer is that calcium carbonate is solid. Because it is insoluble water, or it is insoluble. Yeah, it's insoluble in water. Okay, so next question says, what is the molar mass of magnesium? Okay, so if you guys know magnesium, right? So this is chemically represented as in lowercase g, and this has a power. This is in the group 2, right? In group 2, and we can see that it has an atomic number of 12 and a molar mass of 24.31. And so we're trying to find the molar mass of magnesium. And since magnesium is an element, it is given in your periodic table, the molar mass. So we can say it is 24.31 grams per mole. Okay, so this is very important, the unit for molar mass. As I mentioned also previously, that molar mass is the same thing as your atomic mass. Okay, and so if you guys recall that to find your atomic mass, this is the number, you basically add the number of protons plus the number of neutrons. And so this could also be said for your molar mass, but the more proper way to do it would be to first find your atomic mass, which is basically equal to your molar mass. So, so let's say for magnesium, we're trying to find the atomic mass, and you can see that the number of protons is always equal to your number of electrons, and your number of protons is basically your atomic number, which is 12 for magnesium. We can say this is 12, and plus, so your number of neutrons is basically, in most cases, it is the same number as your number of protons. So in this case, we could also say that the number of neutrons is also 12. So you just add these two numbers together and you get 24. Right? So you can see that the molar mass or the atomic mass is 24 AMU. And this is also equal to 24 grams. Right? You can see that it's nearly the same. And so this is your molar mass. So I would only so this is just generalizing how to derive molar mass from atomic mass if they told you to, but generally you should just look from your periodic table because it's given right there. Okay, and so yeah, so this is the answer for magnesium to find the molar mass. That would be. Next question, number 10. Says, how can you find Ka from pKa? So if you guys recall that Ka is the acid dissociation constant. Right? And so they're telling us to find Ka from pKa. So pKa is basically also a measure of how acidic, probably how an acidic how acidic a solution is. And so pKa is basically, we can say pKa. So we can say that pKa is equal to the negative log base 10, right, of your Ka. Okay. And so to find Ka, you would basically take the inverse of this. So it would be Ka is equal to 10 to the power of negative Ka. So this would give you your Ka value, your acid dissociation. Okay? And so it's correct. And so basically that was the end of our session. If you like this Q&A, please subscribe to the OneClass channel, like, comment, share this video. And if anyone needs one-on-one tutoring sessions or has their own personal questions they want to ask related to this topic or subject, you guys could follow the links down below and ask your questions. Other than that, I am Shanjida, and I'll hope to see you guys soon. Bye bye.